The model that powers ChatGPT and the raw model that came out of training are not the same thing. Between training and deployment, something important happens. It's called fine-tuning, and it's responsible for more of what you actually experience when you use an AI product than most people realize. Fine-tuning is how a general-purpose model that knows about everything becomes a model that's good at something specific. It's how a model that will generate anything becomes a model that follows instructions, stays on topic, refuses harmful requests, and sounds like a helpful assistant rather than a random text predictor. Understanding it changes how you think about the difference between AI models and why two models with similar raw capabilities can feel completely different to use. Let's start with where fine-tuning fits in the overall process. Pre-training is the expensive foundational step. A model is trained on an enormous data set, essentially a large fraction of the written internet, to predict the next token in a sequence. After enough training on enough data, the model develops a broad general capability. It can write, reason, translate, summarize, answer questions, write code, but it's not particularly good at any of them, and it doesn't behave like an assistant. Ask a raw pre-trained model a question, and it might just continue the question as if it were a document, because that's what it learned to do. Predict what comes next based on what it's seen. Fine-tuning comes after pre-training. The pre-trained model, with all its broad knowledge already embedded in its weights, is trained again, this time on a much smaller, much more carefully curated dataset. This second training run adjusts the weights further, specializing the model's behavior without erasing what it already knows. Think of it like this. Pre-training builds a foundation of broad knowledge. Fine-tuning shapes how that knowledge is used. The raw model knows how to write. The fine-tuned model knows how to write the way you want it to. There are a few distinct types of fine-tuning worth understanding because they do different things. The most straightforward is supervised fine-tuning, or SFT. You collect examples of the behavior you want, a question followed by a good answer, a prompt followed by a well-formatted response, and train the model on those examples. If you want the model to always respond in a particular tone, write your examples in that tone. If you want it to format code in a specific way, demonstrate that. The model adjusts its weights to match the patterns in your curated data. This is how companies build domain-specific AI tools. A legal AI assistant is a general model that has been fine-tuned on examples of legal reasoning and document review. A coding assistant is a general model fine-tuned on code, code explanations, and debugging conversations. The underlying model is the same. The behavior is shaped by what the fine-tuning data emphasized. The quality of supervised fine-tuning depends almost entirely on the quality of the examples. If your examples are inconsistent, the model learns inconsistency. If your examples contain errors, the model learns to replicate those errors confidently. This is why large AI labs invest heavily in data curation and annotation. The fine-tuning dataset is small relative to pre-training data, which means every example carries significant weight. One bad example in a dataset of 1,000 can have a measurable effect on the model's output, in a way that one bad example in a billion pre-training documents simply cannot. The second type is reinforcement learning from human feedback, or RLHF. This is what OpenAI used to turn GPT into ChatGPT, and it's more complex. Here's how it works. Human evaluators are shown pairs of model outputs and asked to rate which one is better, more helpful, more honest, less harmful. Those ratings are used to train a separate model called a reward model, which learns to predict what humans prefer. Then the language model is trained using reinforcement learning, generating responses and receiving rewards based on the reward model's predictions. Responses that score higher get reinforced. Responses that score lower get discouraged. The result is a model that has been actively shaped toward producing outputs that humans judge as good, rather than just outputs that statistically resemble its training data. This is why ChatGPT tends to be helpful, well-formatted, and cautious about harmful content. Not because those properties were in its pre-training data specifically, but because human feedback during fine-tuning pushed it in that direction. One important thing to understand about fine-tuning is what it changes and what it doesn't. Fine-tuning adjusts the model's behavior, its tone, its instruction following, its formatting preferences, its refusals. It does not significantly expand the model's knowledge. If the pre-trained model didn't know something, fine-tuning on a small data set is unlikely to teach it that new fact reliably. Knowledge comes from pre-training, which requires enormous data and compute. Fine-tuning is cheap by comparison. It can cost hundreds or thousands of dollars rather than millions, but it operates on top of whatever the base model already knows. This distinction matters practically. If you want an AI system to know about your company's internal documents, fine-tuning alone is not the right tool. What you actually want is retrieval augmented generation, inserting relevant documents into the context at query time. Fine-tuning is for shaping behavior, not injecting knowledge. A common mistake when companies first experiment with fine-tuning is trying to use it to add factual information, training the model on a FAQ document and expecting it to reliably answer those questions. It doesn't work well. The model may learn to answer similar questions in the same tone, but it won't reliably retain the specific facts, and it may confidently produce answers that mix up or contradict what was in the training data. For factual grounding, retrieval is the right tool. For behavioral shaping, fine-tuning is the right tool. Knowing which problem you have determines which solution you need. There's also a phenomenon called catastrophic forgetting. When you fine-tune a model too aggressively on a narrow dataset, it can lose some of its general capabilities. The weights shift to fit the new examples, and in doing so, they move away from representing the broader patterns they learned during pre-training. This is why careful fine-tuning uses relatively small learning rates and monitors performance on general benchmarks throughout the process. A newer technique called parameter efficient fine-tuning, or PEFT, has emerged to address some of these challenges. Instead of updating all the weights in the model, PEFT methods add a small number of new parameters and train only those, leaving the original weights largely intact. The most popular approach is called LoRA, low-rank adaptation. It adds small trainable matrices to certain layers and achieves results competitive with full fine-tuning at a fraction of the compute cost. This is what makes fine-tuning accessible to companies that can't afford to run full training runs on large models. Here's the picture worth holding. Pre-training creates capability, fine-tuning creates behavior. The model that knows about everything becomes the model that's good for you. Every AI product you use that feels polished, that follows instructions, stays on topic, formats things usefully, declines harmful requests, has been through some version of this process. The raw model wouldn't behave that way. The behavior was shaped deliberately by someone who decided what good outputs look like and taught the model to produce them. That has an important implication. Two models with identical pre-training can feel completely different if they've been fine-tuned differently. And a model that seems incapable of something may actually be fine-tuned not to do it rather than genuinely unable. Understanding fine-tuning is understanding the gap between what these models can do and what they're allowed to do. If this kind of precise mental model is what you're looking for, subscribing is how you get the next one.